Good morning. So here we are. It is Wednesday, the 21st of April. And today what I wanted to go over was a lab that most of you have already done, but for the folks who may be online or may have missed the day, I'm going to go over our hot pepper hell lab. Now, remember, this lab was a part of our nervous system. We were testing to see how does the pain response work with something that, while it causes pain, causes no harm. Also, strictly optional. There is no need to eat anything spicy at all to complete this lab, and I'll show you without eating anything spicy and yet being able to answer every question. So let me start by bringing this up. And Shazam. All right. Wonder if DC is going to sue me on that. All right, so here we go. This is the first part of it. And what it's saying is we want to take a look at this, but first let's take a look at our different human body systems. Actually, let me see, can I open this with Cami? All right, now as you take a look, we've got our respiratory system, which we've gone over. The second one has the heart and all the blood vessels. This is our circulatory system. The third one has our stomach and our liver and all of our intestines, the digestive system. And then finally, the other major one that we did for this part of our human body unit, the nervous system. Convert. Now, for each one, I also want you to describe the effect that eating a hot pepper will have. Now, when you're asked to describe something scientifically, what it means is we want to know how is it going to affect that body system. Is it going to increase what that body system does, decrease what the body system does, or will it stay the same? All right, so it should always be based around those three. Let's see. Nope, still working. So for each one, for the respiratory system, say respiratory system, and then tell me, is it going to increase or decrease or stay the same in terms of your breathing rate? And then for the circulatory system, for how fast your heart is pumping. Then for the digestive system, for how your guts are churning and moving food through. And then finally for the nervous system, how much is it sending signals? All those little electrical bits. All right, got it here. We'll bring this one up quite a bit. Great. So we label everything like our respiratory here. And then I'm going to say, let's say it's going to increase breathing. Because, well, I'll tell you, hot peppers, yeah. Like, All right. Now, how does a hot pepper defend itself? If you remember from class, we were talking about this very particular chemical that hot peppers produce in order to keep themselves safe from predators, in order to convince predators, you don't want to eat me. You can see it actually in the next line down. It's called capsaicin. Or you could also say, something along the lines of, they are hot. Now, obviously, we don't mean hot temperature, so maybe the term spicy would be a better choice, but the same idea. It says capsaicin is a protein that will bind to your heat what? So in order for your body to recognize heat, it has to bind to the receptors. Remember, you have receptors for each type. Now, this will provoke a response just like you were on fire, which is true. If you grab a hot pepper and you bite into it, or you're chewing it and your mouth starts to hurt and your lips start, that's literally exactly what it would feel like if your mouth was burning, literally burning. So keep that in mind. I mean, don't try it, please, but that is the same feeling. Now it says below are common predators of the hot pepper. Which one do you think the hot pepper wants to eat it? Circle your choice. All plants want their fruit to be eaten. That's why they make a fruit. An apple was not made by accident. An apple is made with the seeds inside to make sure that something will pick it up, carry it away, and munch on it. Because then the seeds get to move from the parent over here off to some other place. Otherwise, those seeds just drop straight to the ground. And now the parent must fight its own children for nutrition, territory, and things like that. Yes, plants do fight each other. It just doesn't happen as visibly as we like to think of fighting. So, all right. So we look at this. Which one do we think that plants want to eat their food? Well, I'm going to go with the mammals, right? Because I eat apples. I eat spicy things. I imagine they would too. You circle whatever one you think it wants to be eaten by. It says, which of those predators is the most dangerous to the hot pepper? Which one of these three? Well, I don't know. So I'm just going to take a guess. Insects. I'm just guessing because I really don't know. Now, this will help to explain it. What part of the pepper does the plant want to protect the most? What part is the most precious to it? Here's a picture. So which part of the plant do you think is the most important to the plant? The part that it wants to keep the safest and away from harm? Is it going to be the stem, the roots, the leaves, the fruit, the seeds? Like which one of those? All right. So once you've got that, now go back and think, now that we understand, hopefully, what the most important part is, which animal do you think is the most dangerous and why? So now you have a chance with that kind of understanding to go back and go, all right, was insects right? Or do I think that something else is now more dangerous? Recognizing the most precious part of the plant. So just take a second round and say why. So yeah, I think I'm right because I still think they're going to do the most damage. Or yeah, you know what? I think maybe now it's the birds because I think the birds are going to eat more. I don't know. Whatever. Story time. 200 years ago, Christopher Columbus took a break from murdering natives, raping, pillaging, and otherwise being a horrible human being. That break occurred when he discovered the chili pepper. He didn't really discover it. The natives have been growing them for hundreds and hundreds and hundreds and hundreds and hundreds of years. But European history really likes to be kind of self-centered, so they say, oh, a European discovered it. No, they didn't. Columbus took the seeds back to England, and a new phenomenon was born. Within 60 years, every country on the planet was growing hot peppers and adding them to food. Can you imagine Indian, Chinese, or Thai food without spice? Most of us can. Most of us identify Indian food with spicy now, but that wasn't always the case. The pepper itself is a marvel of evolution. In the distant past, it found itself being eaten by all manner of organisms. Birds were the ideal choice, though. So birds are the ones that hot peppers want to eat them. Their digestive system was very short, and birds didn't chew. So the precious seeds wouldn't be destroyed. All right, so there's the most important part of the plant, the seeds. Instead, the seeds would pass through and be ready to grow. But mammals, they grind their food, chewing, crushing, destroying the precious seeds. And so the hot pepper had to fight back. It evolved a special protein called capsaicin, a protein that would bind to the heat receptors in mammal mouths and make them feel pain. When a mammal bit into a pepper, the pain would teach them to never do it again. But meanwhile, since birds don't chew, they would never feel the same terrible pain. Only mammals. Except humans are stupid creatures that enjoy pain and actively subject themselves to it. And if you were here in person or watching through the camera, then you saw that over the last couple of days as we ate continually spicier foods all the way up to Carolina Reaper, which is the hottest pepper on the planet, and many of us were in pain. And so, despite the greatest defense of all natural plants, except maybe just being poisonous as hell, the hot pepper is now sought out for its burn, not protected from it. So now we got 5 questions. And I want you guys to answer these on your own. How spicy do you think the original hot pepper hundreds of years ago was compared to modern hot peppers? Was it more spicy? Was it less spicy? Was it the same spicy? Number 2, give 2 reasons the hot pepper evolved capsaicin. You don't need 2, just 1. It's in the story. Number 3, why do hot peppers want to be eaten by birds, but not by mammals? It's in the story. Number 4, do you think this is an effective defense in nature? Yes or no? In nature, in the natural world, do you think that this works? And finally, number 5, despite the burn, many people enjoy eating hot peppers. Give 1 explanation other than we like pain. I already said humans are stupid and we enjoy pain. 1 explanation other than that for why people might choose to eat hot peppers, even though it hurts them. So pause there, get those done, and then we'll finish up. All right, last bit. Here is a capsaicin molecule coming down towards this weird green thing. The 2 of them come together. The green thing does a thing. Other stuff happens. All right. First, label the receptor. A lot of people miss this. Literally go up into this diagram. It only has to be in one of them. And like if you think these red lines are the receptor, give me an arrow. And include a label saying this is the receptor. Next, what do you think the pink dots might be representing here, right? All right, so the pink dots move through. They say, let's get a message to the brain about this. I wonder, what form of signal molecule might those pink dots be? Next one, how does a receptor work? This is really more of the definition of a receptor. And then finally, what would happen if your receptors were damaged? Let's imagine that you actually injure your mouth. You actually destroy some of these hot receptors. If I pick up a hot pepper, then bite into it, but my hot receptors are damaged, what would happen? Or what wouldn't happen? Explain the result. And that's the lab. There's nothing more than that. Just a little bit in the story of a hot pepper, how we got them, why they are the way that they are, and some background about how it affects the human body. Ladies and gentlemen, I hope that that helps. I hope that any questions you had are answered, or at least this gives you a really good point to leap off in order to complete them. Remember, we will be testing out on all of this material: nervous system, endocrine system, respiratory system, on tomorrow, Thursday. So have a great day, enjoy, and I'll see you in class.